This is project 3 for Dr. Azabe. My name is Nicole Ringel and I'll be showing 2D flow simulation using a combined Poiseuille and Couette flow. So first we're going to double click on Fluent. Click on geometry. We're going to change 3D to 2D. Right click on geometry. Select the new design model or geometry. Should take a little bit to load up. Perfect. We're going to select the z-axis, so we're on the x and y plane. We're going to go to sketching. We're going to zoom in a little bit. Since we're already in meters, our height will be smaller. So rectangle. Perfect. Let's dimension it. We use the height of 0.005. So our length will be 0.75 and our height will be 0.005. Perfect. That's our plate. So now we're going to go to surface from sketches under concept. Select the sketch. We're going to apply. We're going to select the sketch, generate, and there we have our geometry model done. So now we're going to go back to the workbench. We're going to make sure to just update. We're going to go on mesh, double click on mesh. Right, while that loads up, perfect. It's already in the X and Y plane. So first we're going to right click on mesh, insert face meshing, select apply. That will be our face mesh. Then we're going to go insert again, sizing. We're going to select the edges. The top and bottom will be element size will be the number of divisions. Number of divisions for the top and bottom will be 2000. This is just a preference that my partner and I decided upon. And then we're going to go to capture curvature. We're going to select no. Change soft to hard. And that is it for the top and bottom. And then we're going to go here, mesh again, sizing. We're going to do the inlet, hold control, select the outlet as well. And we're going to apply. We're going to select element size and we're going to do number of divisions. Number of divisions here will be 200. Again, preference wise. Capture curvature, same thing. No. Soft will be hard. And we're going to click generate for all of those. Perfect. So here now we can name them. We can click the edge, click N. This is the top wall, the top plate, top plate. Then let's do the same thing for the bottom plate. Same thing for the inlet. As well as the outlet. Perfect. Hit generate one more time, make sure everything's captured. We can take a look at our mesh just to see if everything turned out okay. We have to zoom in a lot since we have so many cells. If you zoom in, we can see the cells here throughout the plate. Perfect. So that's it with the meshing. We're going to go back to the workbench. We're going to update the mesh, perfect, and we're going to double click on setup. Double precision, start. Perfect. Right, it's just loading up. Perfect. Now that we have that, we're going to go to models. We're going to select viscous. We have laminar flow. Click OK. We can close that, and then we're going to go to materials, fluid, air. Here my partner and I chose density to be 1 and the viscosity to be 0.005 according to the tables. So change and create. We're going to close here, and we're going to go to, we can close that. We're going to go to boundary conditions. We're going to open inlet. We can select the inlet here. The velocity is 5 meters per second according to the project. I'll hit apply. We can close that. Then we can go to the bottom plate will be this is for project, be moving wall, sorry. The speed will be, for the bottom, will be -2 meters per second. Direction will be x equals 0, x equals 1, and y equals 0. We're going to hit apply, we're going to close, and then for the top plate, we're going to do moving wall again. Speed will be 3 meters per second. X equals 1, y equals 0. Hit apply, close. Perfect. Nothing to do with the outlet. Everything is good. We're going to go to reference values. And here they have the original density, the default from the ANSYS Fluent system software. So with our new values that we chose, we can select compute from, and we're going to choose inlet, and that is what we had chosen. Viscosity 0.05, and density is 1. So then after that we can go to monitors. Let's close. Yeah, monitors, residuals. We're going to do the residual to be more precise. We can do 6 decimal places, just for more accurate precision. Hit OK. Close monitors. We're going to initialize. Here we're initializing. And then we're going to select run calculation. Here, number of iterations is going to be 200. Everything here should be the same. Number of iterations, perfect. We can hit calculate. Right, this is just taking a little bit. The amount of cells and the amount of iterations we've chosen might take a little bit to load. Perfect, now that the calculation is complete, hit OK. We're going to go to now that we have the setup done, we can go back to the workbench. We can select solution, And here we can go to contours under graphs, select contours. Here we can get our static pressure. Just press save and display. This is the static pressure for the simulation flow. You just screenshot that, put it in your report. That was pretty simple. Okay, so after getting the pressure, we're going to go to contours. Here we can create a velocity contour just for later on if we need it. We're going to select all. We're going to save and display. Perfect. And then we're going to go to vectors. This is where we're going to get our velocity vectors, and we're going to select all, and we're going to display. Might take a little bit because there's just so many. Perfect. Close, and then here we can zoom in. Perfect. You can see the little itty bitty vectors on there. Let's see if I can zoom in a little more. I wonder. Perfect. Okay. Here you can see the little vectors going along the plate. Super, super small. Yep. Perfect. So you would just take this, take a screenshot, maybe zoom in a little for your document, and for your submission file, zoom in a little bit like this. Screenshot it, put it in there, and then this is for the velocity vectors, and then now we're going to get the velocity profile. So the velocity profile, we're gonna go to the workbench. We're going to open results. All right, that's loading. We're going to select X and Y, and then here we're going to alright, so we're going to add a line. This will be the midpoint. Press OK. Point 1 is going to be 0.375 meters. 0, 0. Point 2 will be 0.75. And then our Y will be 0, which is our height. Samples, we can do 100. We're going to click apply. Perfect. The midpoint is right there. And then we're going to add another line. This one will be endpoint. Endpoint will be 0.75, but to be more accurate, 7.495. 0, 0. Point 2 will be 0.7495. And then our height, which is, we're going to do 100 samples. We can click apply. And our endpoint is right there. You can see it right there. Alright, so now that we have the lines created, we're going to add the chart to get our velocity profile. Title will be velocity profile. Data series, series 1 can be midpoint. Location is midpoint. Apply. We can add and then apply. Endpoint. Location is endpoint. Add. Apply. Edit. We don't need series 3. We can apply all of those. Completely forgot to choose the x-axis. So x-axis, we want velocity. Y, we want it to be y. And then let's click apply. Perfect. And right here, the velocity flow. For velocity profile. So you just take a screenshot of this velocity profile and then put in your report. To make it look a little nicer, we can alter the x-axis range. So technically, we would only need from 0.2 to 0.8, and then we click apply. And this is what you could put on your Word document just for easier appealing to the eye. Right, and then to get the maximum velocity and maximum height, we'll go back to the Solutions tab, and we're going to get an X and Y plot. We're going to change pressure into velocity. Velocity will be X velocity, be direction vector. The direction vector will be 0. The plot direction will be 0 to 1. We're going to select all. We're going to add a new surface line. This will be max velocity and height. And that's going to be our length. That's going to be 0. And then X, and then that's going to be 0, and then X1 will be, and then that will be 5. Perfect. We're going to create. We're going to close. And we're going to select that. We're going to write to file. We're going to write it, and it's going to come out. We're going to grab that file, put it in Excel, see the corresponding values to the maximum height and velocity, and we'll put that in our document submission. Part E, we decided to do it by hand, so we uploaded our work on the document for the submission. And I believe that's all you need for project 3. Thanks.